Hello friends, welcome to the channel Physics by IITians, where we are preparing for NET, GATE, JEST, JAM and other physics related examinations. Before starting the video, I would suggest you please watch the previous video which I have made, the introduction of atomic physics or how to solve atomic physics problem, where I have briefly discussed about the history of atomic physics, the Bohr postulate and the finite mass correction of the nucleus, and you will find out the Rydberg constant values and some problems related to previous papers. So please watch that video and come back. So let's start. I have also discussed in earlier videos that Balmer in 1883 had shown that the experimentally determined wave number of the spectral lines of hydrogen in the visible region can be represented by an empirical relationship, and that empirical relationship is nu bar is equals to nu bar is 1 by lambda. So in terms of wavelength you can find out the relation as a equals to 1 by 2 square a into 1 by 2 square minus 1 by n square, where a is the constant and he take different values of n, like n equals to 3, 4, 5, and he find out the values of a to be 1.09678 into 10 to the power 7 meter inverse. Now Bohr theory, from the Bohr theory we get that En equals to the energy level, the hydrogen atom En is minus 2 pi c h cross r infinite z square by n square. R infinite is the infinite Rydberg constant for the assuming that the nucleus to be infinitely heavy and it is assumed to be at rest. Now the Bohr's theory gave us the value of the nu bar is r infinite into z square 1 by nf square minus 1 by ni square, where r infinite from the calculation we get 1.09737 into 10 to the power 7 meter inverse. Look, the empirical relationship that calculated by Balmer, the a value is 1.09679 into 10 to the power 7 meter inverse, where from Bohr's theory we can get the value 1.09737 into 10 to the power 7 meter inverse. Look, these values are quite similar. Okay, let me use a pen so that you all can understand. This value and these values are quite similar. Now let's go to the other page. Before the discussion, we should briefly discuss about the spectral series of hydrogen atom, because this is very much important in your interviews, like for the MSc interviews, also in the MSc entrance questions and BSc questions also, you should have a detailed, clear idea of the spectral series of hydrogen atom. So whenever you are writing this, that is nu bar equals to 1 by lambda, that is equals to r infinite into z square into 1 by nf square minus 1 by ni square. So according to Bohr, the first postulate of Bohr give you the quantization rule, that is the electron has an angular momentum L, and for the stationary orbits the L should obey the relationship L equals to n into h cross. And for the second rule, whenever the electron revolves in a stationary orbit, it doesn't emit any electromagnetic radiation, so the stability of atom is explained. The third postulate is the emission of electromagnetic radiation from the hydrogen atom or hydrogen like atom takes place when the electrons make a transition from one stationary orbit to another, that is the transition from any higher state, that is E2, to an orbit of lower energy, that is the lower state, that is E1, and the emitted radiation will be h nu equals to h cross omega equals to E2 minus E1. So what does it mean? That the energy level, suppose you are getting the r infinite into 1 by nf is the final state and ni is the initial state, where the electron has jumped to the lower state. So we all know that emission of radiation will occur when electron from higher state jump to a lower state, and absorption of radiation occurs when electrons from the lower state will jump to an higher state. Okay, so in spectroscopy you have to know that what do you study? In spectroscopy we study the emission spectrum or absorption spectrum of molecules. Now what do you mean by emission spectrum? What do you mean by absorption spectrum? For emission spectrum, suppose the material which is exposed to some radiation, electromagnetic radiation, and if you have some spectrograph, okay, so for film, spectrographic film, and you get certain lines which was not present earlier. So this certain lines gives you that these lines are originating from the emission spectrum of that atoms or molecules, that the atoms or molecules has been excited, and it come back to its ground state, and it will emit radiation of certain wavelength, and that is present within that spectrum series or within that spectrum. So you have to find out, calculate the wavelength that is present within this spectrum, and from that wavelength calculation you can find out the energy levels, because we all know that h nu equals to, that is how energy levels and wavelengths are related, that is h nu equals to E2 minus E1. Sorry for the inconvenience, the writing is not clear, but please do understand it. So h nu equals to hc by lambda, and hc by lambda equals to E2 minus E1. So if you calculate lambda or nu, you can directly relate it to the energy of the energy levels of that atoms or molecules. From there you can find out what is that unknown atoms or unknown molecules, or certain, you are studying the absorption spectra. Absorption spectra means the certain radiation electrospectral lines are missing, okay. So the if certain spectral lines wavelengths are missing, then you have to understand that it has been absorbed by the atoms or molecules, so it is absorbing the exact energy which it is required to go from a lower state to a higher excited state. From a absorption spectra also you can find out the unknown or identify the molecules or atoms present in a material, okay. So exactly what I am trying to tell you, that from the spectrum of any atoms or molecules, we can have detailed information about the energy levels. Right now we are only studying the energy levels of electrons. In some other classes we will study the energy levels of the vibrational energy levels, the rotational energy levels. You can find out from the rotational energy levels, you can find out the distance between the nuclei. So it is a very important topic that was done or initiated by Bohr, okay. So you have to understand it very thoroughly. So if the final level is 1, and the atoms are already, electrons are present in the higher state like n equals to 2, 3, 4, etc., then from 2, 3, 4 it will come back to the 1 state, and we will get the Lyman series. That is, nu bar will be R infinite 1 by 1 square minus 1 by n square, which falls in the UV region. Now Paschen series give you that the in nu bar equals to, for Balmer series is, the Balmer series, that is the final NF will be 2 and NI will be 3, 4, 5, fall in the visible region. The Paschen series is NF equals to 3 and NI will be 4, 5, 6, that will fall into infrared region. Then NF equals to 4 and Ni equals to 5, 6, 7, that fall in bracket series, and NF equals to 5, Ni equals to 6, 7, 8, that will go for Fund series or Fund series. The origin of spectral lines or series can be easily understood from Bohr's theory. So you have to understand how the spectral series of hydrogen atom we will get. And look here, the Balmer studied the visible region because it was at that time the visible. So we don't have so much high technology to detect all the other regions wavelengths, but he can easily detect the visible region. That's why this is the Balmer series. Okay, now let us think is physically. So this point is the nucleus, the small point is the nucleus, and this are the n equals to 1, n equals to 2, n equals to 3, n equals to 4, n equals to 5, n equals to c, the different radii. different orbits. So Lyman series means from n equals to 2, 3, 4, 5 or higher levels, the electrons are coming back to one level, that is first energy level. Balmer series gives you from n equals to 3, that is n equals to 3, 4, uh, 5, 6 or higher to n equals to 2. Or the Paschen series n equals to 4, n equals to 3, that is coming from n equals to 4, n equals to 5 or higher levels. Bracket series, that is coming to the n equals to 4, that is the final state, from n equals to 5, n equals to 6. Fund series or Fund series coming at n equals to 5 from n equals to 6, n equals to 7 or higher. Okay. So this another important question is, in the interview usually teacher asks draw the energy level diagrams of the hydrogen atom. So the energy levels, you don't ever do a mistake that energy level diagram, you don't make it the equally spaced, okay? Because the energy En from the Bohr theory also we get that En equals to minus 13.6 by n square. This will be in electron volt. Let me erase it and write it clearly. That is, energy is in electron volt. So this is En equals to minus 13.6 electron by n square electron volt. Now the n equals to 1 state, that is Lyman, from 2, 3, 4, that is coming. N equals to 2 state, that is we get Balmer series from 3, 4, 5, and then Paschen series, bracket series. And what will be the spacing between the energy levels? N equals to 1, so you have to put n equals to 1 to this formula. So minus 13.6 electron volt. Now n equals to 2, it will be minus 13.6 by 4. N equals to 3, minus 13.6 by 9. N equals to 4, minus 13.6 by 16, because 1 square, 2 square, 3 square, 4 square. So the spacing between the energy levels will be lower, lower, lower. So you have to, this is a very important diagram. You have to understand it. Okay. And for n equals to infinite, this is continuous. What do you mean by continuum? Because whenever you put n equals to infinite in this energy level, you get En equals to 0. Okay. Now what do you mean by En equals to 0? Whenever the electron are inside the hydrogen atom, they have discrete energy levels, because they have certain n equals to 1, they have certain energy levels, at n equals to 2 they have certain energy, at n equals to 3 they have certain energy. But whenever they are escaping from this bound state, that is they are not inside any atom, the electron can have any energy, or it can have any continuous energy. Okay. Now I have told you the electron volt. No, you should know the basic definition of electron volt. The electron volt is the energy acquired by an electron when it is accelerated through a potential difference of 1 volt. So 1 electron volt is 1 electronic charge into 1 volt. Now 1 electron charge is 1.6 into 10 to the power minus 19 coulomb. I am sorry, this is not 9. This has been just missed, writing mistake. This is a minus 19 coulomb into 1 volt, that is 1.6 into 10 to the power minus 19 joule. Now there is a very important concept of ionization energy. So ionization energy is the minimum energy required to set free an electron originally bound in the lowest energy level. For hydrogen, there is 1 electron and it should be at n equals to 1 for its ground state. So for hydrogen, what is the ionization energy? E infinite is 0 and E1 is minus 13.6. So you will get plus 13.6 electron volts. So ionization energy is positive energy. What will be the ionization potential? Ionization potential will be 13.6 volt. Okay. Now effect of finite mass. Earlier I told you that whenever the nucleus is not infinitely heavy, then nucleus as well as electrons both are revolving around a center, around a common axis. And we find out that we should replace the mass of electron Me with a reduced mass, that is mu equals to small m divided by 1 plus small m by capital M, where small m is the mass of the electron and capital M is the mass of the nucleus. And the Bohr condition will be modified and it will become L will be mu into r square omega equals to n into h cross, where omega is the angular velocity, and r infinite will become Rm, and Rm will be, the Rydberg constant will be Rm equals to r infinite into 1 r infinite divided by 1 plus small m by capital M. Okay. Now, what is the difference between the Bohr quantization and the Sommerfeld quantization? Sommerfeld told us, instead of Bohr, that is, he took only the circular orbits, but Sommerfeld thought that this is first of all, the orbit can be elliptical as well. Why is it so? Because the electrons are experiencing a Coulomb potential, that is inverse square, that is force is F equals to proportional to 1 by r square, and the energy of the particle is negative. So the orbit is circular only as a special case. For example, we know from Kepler's law that planets revolve round the sun in elliptic orbit with the sun at one of the foci. The force acting on the planets is the gravitational attraction of the sun, which is of the also of the inverse square type. So since the electrons in the atoms are acted upon by the Coulombic attractive force of the nucleus, which is also of inverse square type, there will be in general described elliptical orbits as long as they are bound in the atom, that is negative. So he considered two things. One, that is F is proportional to 1 by r square and electron is energy is negative. So orbits are circular only as a special case, rather it is elliptical. Now, the elliptic orbit of an electron, you have to describe its coordinate or position by two polar coordinates. One is r, another is theta. So I have shown it the diagram. This is the nucleus, this is the electron. The distance between electron and the nucleus is r, and the making an angle theta. Now the periodic change in r and theta, because it is a periodic motion, and theta will be changed from 0 to 2 pi in one complete revolution, and r will change from r minimum to r maximum. Okay, so r minimum position when it is closest to the nucleus, r maximum position when it is the far away from the nucleus, and the closest position is known as perihelion, and maximum or farthest position is known as aphelion. Now in 1960, he find out the generalized rule for the quantization for the periodic motion of a particle having one or more than 1 degrees of freedom. So in case of the electron revolving in an elliptic orbit, there are two pairs of periodically varying coordinates and their conjugate momenta. According to the Wilson-Sommerfeld quantum condition, the quantization will be the closed integral over PR dr equals to nRh, and closed integral over p theta d theta equals to n theta h, where nr is the radial quantum number and n theta is the orbital or azimuthal quantum number. So only this can have only integer values, integral values. So for circular orbit, we all know that r equals to constant, so theta can change from 0 to 2 pi, and p theta is the angular momentum that will remain constant under the action of a central force. So for circular orbits, the closed integral over p theta d theta will be p theta integration over 0 to 2 pi d theta, that is 2 pi into p theta, which is n into h. So p theta equals to nh divided by 2 pi. So this is exactly matching with Bohr's condition for Bohr's quantum condition for circular orbit. So Sommerfeld condition is easily verified with the Bohr condition. So Sommerfeld have taken rather a general rule of quantization, that is the r as well as theta. Okay. So these are the two quantum conditions, one which giving you the radial quantum number and another is giving you the orbital or azimuthal quantum number. One is denoted by nr, another one is denoted by n theta. Now this p theta, we can write it as p theta closed integral over p theta d theta equals to 2 pi p theta, that is k into h from the Bohr condition, or we can write it as, or from the Sommerfeld condition, p theta equals to k k into h cross. So k is also can have only integer values. Now Bohr did some simple calculations from the consideration of the elliptic orbit, that we all know the formulas, that radius for the elliptic orbit r equals to a into 1 minus epsilon square by 1 plus epsilon cos theta. And we also know that b and a, if the b is the semi-minor axis, a is the semi-major axis, then root over 1 minus epsilon square b equals to b by a, epsilon is the eccentricity. And he calculate, after calculation he get that b by a equals to k by n. Okay, so n is, or you can write that he get that 1 by root over 1 minus epsilon square equals to 1 plus nr by k, that is k plus nr, he take is another quantity, that is n, should be n by k, or b by a, he get k by n, where n is the principal quantum number, that is the sum of the radial quantum number and the azimuthal quantum number. Now since it's a very important concept to understand, that since b is less than a, so k should be less than n or equal to n. Okay, so for circular orbit b equals to a, so epsilon also is 0, so k will be equals to n. So nr equals to 0, the radial quantum number nr is 0, so nr can be 0, but k cannot be 0. K will always start, the minimum of k value is 1, so k will always start from 1 2 3 up to n. So if k equals to 0, what will happen? If k equals to 0, then p theta will be 0, and p theta will be 0 means the electron would execute simple harmonic motion through the nucleus. So this is not the case. The electron is revolving around the nucleus. So k here is never 0. Okay. So azimuthal quantum number k minimum value is 1. Now nr will be n minus 1, n minus 2, n minus 3 depending upon the value of k. That is the radial quantum number. Now the energy will be, he calculated energy will be, and as m into z square e to the power 4 divided by 32 pi square. This will be minus sign, so minus m into z square e to the power 4 by 32 pi square epsilon naught square n square h cross square, the same as Bohr's theory. So there was no calculation, the inconsistency with the Sommerfeld and the Bohr. So from here what we learn that the total energy doesn't depend on the azimuthal quantum number k, it depends on n only. This is a very important point. From the Sommerfeld we get that the total energy E is always dependent on n, not on k. And also the A, that is the semi-major axis of the ellipse, is depends only on the n and independent of the k. So for a fixed value of n, k values are different. So we can get, for a fixed value of n, we can get different orbits, different elliptic orbits. So the electron has the same energy while revolving these different orbits. So although the orbits, different orbits, but if n value is the fixed, that is n is equal for different k values, the electron has the same energy, and this will be a degenerate system. So the orbits are different having the same energy value are called the degenerate system. This is a very conceptual question that you may be asked. In fact, in BHU entrance exam, the question has already been asked, this question, that electrons in the different k values of the different elliptic orbits has the same energy or different energy. So you have to know for a fixed n, although the k values are different, that is the different elliptic orbits, but the electrons has the same energy while revolving around these orbits. Okay, and these systems are called degenerate system. Now I have some questions. So the Bohr model gives the value of ionization potential of lithium 2 plus ionized 13.6 electron volt, 27.2 electron volt, 40.8 electron volt, or 122.4 electron volt. Now En is proportional to how much? En is proportional to Z square. So here lithium 2 plus, for Z, lithium equals to Z equals to 3. So it will be 3 square. So it will be 9 into 13.6, that is 9 into 13.6 electron volt, and it will be 122.4 electron volt. Another question is, electron jumps from Ni equals to 4 to Nf equals to 2. The initial state is the 4 and the final state is 2. Now one get the first line of Fund series, the second line of Lyman series, the second line of Paschen series, the second line of Balmer series. So go to that energy level diagram, that from n equals to 4, see this is n equals to 4 and this is n equals to 2 line. So from n equals to 4, this, look at this, from n equals to 4 to n equals to 2 line, we get the Balmer series. Okay, so n equals to 4, this is the n equals to 4, this, so we get the second line of the Balmer series. This is the first line, that is n equals to 3 to 2, this is the second line, that is n equals to 4 to 2. So the answer will be the second line of Balmer series. Now you have a homework. The given the mass of muon is 207 times that of an electron, the ionization potential of a muonic atom is of the order of how much? Please solve this question. If you have solved it, please upload it to our Telegram channel Physics by IITians official, and also you join the channel Physics by IITians. We have both the channels. One we only can post, and in the other channel Physics by IITians official, you also can discuss and you can upload your problems or answers. Okay, hopefully you enjoy the class. The next time I will briefly discuss about the black body radiation. So hopefully you enjoy today's lecture. Thank you so much.